So, hello everyone. It's nice to see so many of you here. I hope you're Android developers because this is an Android topic, but I guess because you're here, you are. So I'm István. Welcome here, and this talk will be about Compose View interop features. Before we start, if you're the kind of person who want to backtrack the slides or go forward or just look around in it or follow the talk in your own pace, then you can scan the QR code, which should be there, right? So now, if you scan that QR code, I'll leave a couple of seconds for you to do that if you want to, so you can follow the slide in your own pace, backtrack it, or whatnot, do as you like. OK, still see phones in the air. OK, just take your time. OK. Yeah, still one phone in the air. Cool. Right, and another one. OK. Sorry, folks, I need to continue because we're on a schedule. OK, so what this talk actually will be about is these Compose View interop features. We'll be talking about how to use Android View, Compose View Adapter, Abstract Compose View, and we will touch hybrid UI testing a bit in each case that we will be examining. So the question might arise, why? Why would we use these interoperability features with Compose and Views? Why don't we just use Compose by itself and be done with it? Well, the case is not that simple in the real world, because in a complex project or a project that started a couple of years ago, maybe with data binding or view binding or these kind of things, then you might have a lot of legacy code to cover, and you might not have time to rewrite the whole thing in Compose or well, your employer might not want it because it's a cost. We will be touching these points a couple of times during the slides. OK, let's say that you have complex custom views already implemented or whole screens in views. That's the most likely case. Then you might want to consider using Compose interoperability features if you want to move forward with a Compose adoption. Also, if your project has some UI libraries that are still not updated to Compose, or maybe they will never be, but they are still relevant, you might want to look into the interoperability features. And also, we are engineers. We like the new stuff. Compose is also awesome. So if you want to adopt it or implement new UI components, whole screens in Compose, then you might want to interact with the old part of your code. And of course, there are these things that we don't like anymore, right? So with this, you could just trash them and re-implement some parts in Compose, and just don't care about these things. OK, let's go to our first case study, using views in Compose with Android View. What we'll be looking at is this simple example. And before we actually dive into some code, let's see why this case exists at all. Well, if we want to include existing views in Compose UI, the reason for this might be that we don't have the resources. I already touched this, right? We don't have the resources, time, people, engineers, or a business case to finance our passion towards Compose to rewrite our existing custom views in our projects. Or, as I also mentioned before, using components from a library that doesn't support Compose yet. OK, let's see some code, right? You don't have to actually parse this right now. It's just a custom view. It's the button that you've seen in the previous slide. So it's that. It's a simple example, but it could be like anything in your project that is widely used. This button itself is just supposed to be able to display a text or display a progress indicator if we so like. OK, let's see how to integrate that into a Compose screen. We have this Android View demo screen composable here, which is a scaffold that signals that it's a whole screen, or not, of course. There is a toolbar to render that toolbar there, and in the content, there comes the interesting part. We can use this Android View composable, which is literally just another composable. You can add a modifier and whatnot to it. So we can call this to integrate our existing views inside a composition. And now the interesting part of Android View is the two callbacks that it accepts or requires. The factory callback is the first of them. In the factory callback, you have to provide a lambda that gets a context as a parameter. that context is actually the screen's context or activity context or whatever context you get in these kind of situations. And then it's your responsibility to inflate or create or instantiate a view there and return it from that Lambda. It's kind of important to notice that while you can interact with this view using apply from Kotlin or anything, you can manipulate this created view here. Basically, you shouldn't, and we'll get to that in a minute. So this factory callback is actually called when the Android view composable enters the composition. So when it enters the composition, you can instantiate a view, and that view will be stored with some mechanic inside Android view and in the composition. The other callback, which is important, is update, where you actually receive the view that you created in factory, the stored instance, of course, and you can do some manipulation on it. You can set the text of this button, add callback add the click listeners, any callbacks you want to. So you could just manipulate the view like you would normally do in an activity or a fragment. When this update is called is, well, on every recomposition, including the first composition. So that's why you shouldn't be actually setting up your views inside the factory callback, but in the update callback, because it will be called on the initial composition as well. But currently, the update functions implementation is well, static, but the fun thing is you can observe a state here, and the update function will track that state changes, and Android view will recompose what you have in this update function. So it will actually update the view there if you pass in a state and that state changes. Awesome, right? What is also awesome is that this also works in the preview by default. We get that for free. And in Compose preview, of course. And the other great thing is that it also works as an interactive preview seamlessly. So if you have a complex view with any kind of with any kind of deep complexity or a deep view hierarchy, you can just include it in Compose, and it will work. Also, the other case that we touched a couple of times already before is when you have a library that doesn't really support Compose yet. Actually, it might. I'm not really up to date with MP Android chart now, but it's still a relevant library at this point, right? So you could easily do just that with Android view, and it will also work. OK, now we have this hybrid screen situation with Compose and View mixed together in a bunch. And we would need to test this somehow, right? We should test screens somehow. Well, if you're lucky enough to have screenshot tests already set up and thought out, and everything is working in that department for your project, well, you get screenshot testing for free this way, because we're just comparing pixels with pixels. It doesn't matter if it's a View rendered pixel or a Compose rendered pixel. That's great. But what if we want to actually exercise the layout and check if things are actually displayed there, the old way? Let's get back to our screen, and let's write a test for it. It's a really simple test. We will just test if the button was clicked, so the click listener of the View button is actually invoked when we want it to be. So first of all, we are dealing with Compose, so our tests have to be Compose aware. So then we create this Compose test rule according to the docs and do some Compose manipulation there. We are testing behavior, so we'll have this variable, which is pretty much a flag, and we will set it to true if the button is clicked. We call setContent on the Compose test rule, which is the entry point for our composable, where we can add any composable into the test. And we call the Android View demo screen here, and the trailing lambda actually for this function is the button's click listener. This is a simple scenario. And then in Compose tests, there is seamless interoperability with Espresso. So we could just call any Espresso function like normal, like we did with views, do assertions, do exercises on our UI, and actually it will work. And then, if everything really works, then we will assert if the button was clicked. And if you would run this test, this would actually pass, and we will be happy. Let's see the other way around. When we want to add Compose stuff into View screens, there is a view for that. and it's called Compose View. The scenario is pretty much the same, just the other way around. We have a toolbar which is on a view screen, and we want to add that the Compose implementation of the same kind of button, or actually any kind of custom UI component. Okay, so when we would want to do that? Well, of course, we want to try Compose. We want to add it to our existing, mostly view-based legacy project. Yeah, we want to do that once you adopt Compose. But we would have to use these new components that we create with Compose in existing view-based screens, like a small view refactor. You need to change a component to another component. And you don't want to use views anymore for any reason. There are a couple of reasons, right? You could go the Compose View way. Let's see the example here with some code. Simple screen requires a simple linear layout. There is the toolbar set up there. And what we can do is we could add the Compose view in this layout. On the right side, now you can see the preview of this layout in the layout preview of Android Studio. And as you can see on the Compose view, there is an ADP padding, but nothing else is actually rendered. It's because Compose view itself is designed to host a composable, but at this point in the layout preview phase, it doesn't have a composable to render. We have to do some setup to actually make that work. Also, just note that Compose view is actually behind the setContent function when you call setContent from Android X activity on an activity. And it basically sets Compose view as the view of the activity, and it hosts the composable there. So even though you might not have used Compose view directly, you actually used it indirectly if you set composables to an activity. Okay, let's see how to populate that Compose view there. Okay, for this, let's set up an activity around our existing setup. Regular view binding kind of setup for an activity. There is the onCreate where we set the binding root. Nothing special there. But then there is some special things here. On this Compose view that we get by having this binding, we could do a couple of things. There is the view composition strategy, which I won't go deep into. Let's just say that it controls when the composition of this Compose view is recreated or destroyed, disposed of. What actually matters for us now is this setContent function, which is analogous to the activity part from Android X activity. It's the entry point from the view world to the Compose world. So in this setContent, we could actually call, or we can actually call, composable functions. So let's do just that, call our custom button. And then if we run this example, we would get the button in that view-based screen rendered and ready for action. The preview won't work still, because this is just runtime code, and the preview don't know about this, actually. Be aware that whenever you add the Compose view to your layout, that Compose view will host its separate new composition. So that might make things a bit more jittery, use more memory, and so on and so forth. So just be mindful about using many Compose views inside your layouts. Okay, again, let's get back to testing. We have another hybrid situation here with a bit of a twist. So when we are creating a test for this situation, when we have an activity, we should create our Compose test rule differently. We should use the create Android Compose rule. In the previous example, it was just create the Compose rule. We couldn't see that, it was off screen. You can imagine it. But yeah, create Android Compose rule lets us instantiate a specific activity. So we do just that with our demo activity here. And then we write the test. The other parts are similar to the previous phase, but the actual exercise and what we do in the test is just, now we'll check that the view-based toolbar is there. It will be, simple espresso. And then we could also simply use the Compose testing things to exercise our Compose-based parts of the screen. And this will work seamlessly. Okay, let's backtrack to the point where we added the compose view inside our layout, and the preview didn't actually show anything because there wasn't any composable for the preview to be shown. Let's tweak this. There is an API for that, and it's called Compose View Adapter. Compose View Adapter needs to wrap a compose view in the layout to work, and it's supposed to show a specific composable that we can set to it, so that our preview actually does something for the compose view. And it also supports parameterized previews. We'll see how that works in a second. Okay. So let me introduce you to this new composable that you might want to implement with Compose. It's based on a simple pager, which is, again, really easy to implement with Compose. A couple of lines. And based on a model, it just renders some banners there. And you can just page between them. This is quite easy to implement with Compose, a couple of lines, but with a recycler view or pager, it requires much more. So why wouldn't we implement this with Compose? Okay, this setup consists of some composables and some components that we'll go through quickly. The banners composable itself is just responsible for rendering these banners based on a list of banner data. There is this banners preview data provider that provides us with some data sets for our previews to render. And there is a banner preview, a banners preview, which gets data from that preview parameter provider. And there is a single banner preview, which actually renders the first line up top. OK, so let's put this into context. This is a screen for this example. There is a material toolbar, and there are two placeholder views that you might want these banners to be placed between. So let's try to do just that. Let's add the compose view to the layout. And as before, we can't see any change here in the XML preview because compose view doesn't know what to render here. If we look at the blueprint view of the preview, it supports that. There is nothing, just padding between the two placeholders. Let's change that. OK, so now we wrap our compose view with a compose view adapter, which in the layout inspector, so just in tooling time, we'll be able to render something into the layout preview. There are a couple of attributes that we can use for compose view adapter. One of these is the most important, is this tool's composable name. This requires us to pass a string which contains a fully qualified name of a preview composable function. It's a bit quirky because it's stringly typed. And why that is that compose view adapter actually uses reflection behind the scenes to resolve the fully qualified preview function. We pass there, and it will render it in the preview in edit mode. So now our preview will look like this. And compose view adapter succeeds in rendering our preview. Now, this is kind of a workaround for not having this functionality on the compose view itself, but you might want to use it, you might not, but yeah, this works. Also, just to note that compose view adapter in production, so if you build the app and you're not examining the layout in the layout preview, it will do nothing. It will act just like a frame layout, so it will add minimal overhead in runtime. Okay. And the space is actually there. We can see in the blueprint, and we can see that the view actually now has a height. So it's not a zero height something in our layout, but it actually has height, and it's not just the padding there. Okay, let's tweak things a bit more. Now let's set the banners preview for the compose view adapter. And let's examine the other attributes that we can use. There is this parameter provider class attribute, where we can, again, add the fully qualified name of a preview parameter provider class implementation. And with that, we can control what is actually shown from the preview data provider dataset in the preview. For that, to control it, we also have this parameter provider index attribute. By default, it it's 0. So the 0th or the first element is rendered from the preview parameter provider. But we can actually manipulate this to be any other data set that we have that is provided by the preview parameter provider. So beware when you're doing this, because all of these parameters are stringly typed. So if you mess up something, then your layout won't render in preview. Of course, it doesn't have any retributions in runtime, but your preview might break if you don't do the correct stuff here. This also means that the parameter provider index has to be correct and not out of bounds. Just something to keep in mind. Okay, these were the simple scenarios, and let me introduce you to another API with by an idea that might be a bit abstract first, but yeah, just let's see, and you'll find out what it is. So the idea is to use Compose UI components to render your existing views without modifying those views on the interface level. When would you do this? Well, if you have a design system of some kind, you might have a lot of views already implemented, used in a lot of places in the application, you know, by changing the interface of those, you might have to change a lot of other places in the code, and you might not want to do that. But you might want to use Compose to render these views. You'll get the gist of it. So let's get back to our humble Compose view component. And as we could see before, it's really easy to use. We can set any kind of composable to be rendered by Compose view in runtime. So let's dive a bit deeper into the implementation of Compose view. And as you can see, Compose view inherits or implements abstract Compose view. That's a good lead. We'll get back to that in a second. Compose view has this property called content, which is actually a mutable state of a nullable composable. This is the composable that will be rendered. And yeah, it can change in time. So it's a state, and it's observable by Compose, right? And there is this content composable, which comes from abstract Compose view. Is the only thing that you actually have to override when you're implementing abstract Compose view. And it itself is a composable function, so it's the kind of entry point that set content is for activities or Compose view itself. And this is where we call that content composable that is resolved when the view is created. These are good ideas. So let's try to use them. Again, the goal for this is to render views with Compose. And abstract Compose view, if you look into the documentation of it, it says that it's a base class for custom views to be rendered by Compose. So this is exactly the thing that we were looking for. Cool. Let's do something with that idea. Let's implement a custom button, which might look like this on the constructor level. And as a custom button, previously, you could implement it like in any number of ways. It can be a frame layout, it can be a constraint layout, it can be a button, of course, by itself. But let's change this implementation into an abstract Compose view, and let's see what we can do with this idea. The composable that we want to render this custom button view is here. It's a custom button composable. It does pretty much the same thing that the buttons did before in the beginning of the talk. So you can set a text, you can set it to enabled or disabled, or you can set if it's displaying the loading progress bar or not. So yeah, let's see how we can use this composable to render custom button. In custom buttons init block, we can do some resolutions, like usual, from the typed array, from the styled attributes. Because if you have a custom view, you probably have some custom attributes to go with that as well, if you want to control the custom stuff from XML. So if we have that, we can resolve some attributes like this. Nothing fancy here, actually, if you've implemented at least one custom view with custom attributes before. The interesting thing is there. We resolve the text, the enabled state, and the loading state from the typed attributes, but what we set them to if we want to follow up with this idea. Well, those can be mutable states. We've seen the same pattern in Compose view, so why wouldn't we use this to achieve our goals? So now we have mutable states inside a view. That's great. Why is it great? Because if our custom button is an implementation of abstract compose view, we have to override the content composable. We can call any other composable inside that composable. And with that, we can also observe those mutable states inside the view instance. So if those states change for any reason, with like custom setters or with new attributes being set in XML or whatnot, then this composable will actually recompose and reflect the updated state in our app with this implementation. Also, these kind of abstract compose view implementations now do have a composable to render in the preview. So if we do that, we get the preview for free with this setup. For historical reasons, I included this because there was a time when this wasn't so trivial to do. Because there was a bug in Android Studio before Giraffe Canary 8 that prevented the previews from rendering if we had this kind of setup. Now it's OK. So I see your faces. You might wondering, but why should we or why would we do this abomination that I just showed you? And my answer is there is a talk for that. Please check it out. There is an explanation on why this might be a use case for you if you have virtually infinite time and very enthusiastic engineers. But yeah, we don't actually have much time to go into details on this one. It's just food for thought, let's say that. So wrapping up, here are some resources that you might want to check out if you want to fiddle around with Compose view interoperability features. Yeah, take some photos of that. That's good as well. But you have that on the slides that I showed you in the beginning. So yeah, OK. And yeah, to actually wrap things up, here are some thoughts to take away from this talk. So if you have a big, let's say, legacy code base, a big view-based code base, and you want to start adopting Compose, you can do it gradually with the interoperability features, hard word. So you can include your new Compose stuff in the existing view-based layouts. You can include your existing custom views if you don't want to re-implement them in the new Compose screens. If you decide with your team that the way to adopt Compose is to implement new screens altogether with Compose, you have the option to do these. And while you're doing it, hybrid UI previews and testing are supported. They need a bit of a thought to engineer properly or for your specific use case and setup, but it's possible and you can do it. But in the meantime, if you include too many Compose views inside your view hierarchy or do too much hybrid UI things in your existing setup, that might have a performance and maintenance impact. So just keep that in mind. Don't over-engineer things just because you want to adopt Compose to your legacy part of the code base. Yeah, as always, use the right tools for the right job and don't rush migrations. That's an overall good advice. And with that, Jacqui, I guess that's the word. So yeah, thank you all for being here and for listening. And if you have any questions, just put it on Slido. I will open it shortly. But if you want to just catch up with me, I'll be around all day. Yeah, have an awesome conference. Thank you.
So now we have time for questions. Can we see Slido? And you can put more questions there. István?
OK. I see the questions here. So the first one is, did I have any issues with using Compose view, performance, and animations? Well, actually, I'm currently not using Compose view that much, but a couple of jobs before I did. And we actually didn't experience any significant jitters in the production app back then. I can safely say it was tier, but yeah, there weren't any such implications in production with Compose View. Okay, next one. What about performance overhead when switching between these two worlds? For example, the Compose view in Recycler view and vice versa. Okay, that's a good question, and it has been an issue for quite some time for the Compose team. If you implement your items with Compose view, then a couple of versions ago, it had a really bad performance impact. It caused jitter on scrolling and so on and so forth. But now the Compose team managed to, I don't know the exact version when, but now they managed to tweak the recomposition strategy and the view disposition strategy with Compose view so that when a Compose view is inside the Recycler view, it behaves a bit differently. So that improves performance. Of course, if the composable recomposes too much or so on and so forth, has animations inside them for whatever reason, that might cause issues. But for the regular use cases, static items in a Recycler view with Compose, that shouldn't be an issue anymore.